This is a quick review on how to simplify radical expressions. A radical expression is an expression that has a square root. Another word for that is a radical. So simplifying a radical just means removing any perfect square factors from inside the radical. The resulting expression, which still has something left over inside the radical and has a coefficient outside, is called a mixed radical. So if a question asks you to write each as a mixed radical, that's what it's looking for. As an example, this is a radical expression and has something underneath the square root sign. And to simplify that, I want to break this up where 72 is written as a product of factors where at least one of them is a perfect square. And in the case of 72, there's actually more than one way to do that. 9 times 8 are two factors of 72, and 9 is a perfect square. And 36 times 2 are two numbers that multiply to 72, and 36 is a perfect square. So in the case that there are two options, you want to pick the one that has the largest perfect square possible. Otherwise, if you pick 9 and 8, let's say, it just would have been reducible again. If you pick the largest one, it's done in one shot. The part that is a perfect square, I'll remove from the radical. I take the root of it, which you could just skip to this step here, and write that that's equal to 6 root 2. That is a mixed radical. If I had something that had exponents in it as well, variables with exponents, I would do the same thing with the coefficient. And x to the power 5 and 1 to the power 7 are not perfect squares because for variables with exponents, a perfect square means that its exponent is divisible by 2. So I'd again have to break these up into perfect square factors and whatever's left. 20, for example, breaks up into 4 times 5. I chose that instead of, let's say, 2 times 10 because 4 is a perfect square. And for exponents, because the exponent has to be divisible by 2, the power has to be divisible by 2, what I'll do is break these up into the highest possible even power, and then whatever's left, which would be 1. So x to the power 4 is a perfect square. It's x to the power 2, x squared times x squared. And x to the power 6 is a perfect square. It's x cubed times x cubed. So all of these are perfect squares. That's a perfect square coefficient, and these are perfect square variables. And what I'll do is I'll remove all of the perfect squares from inside the radical. So 4 when it comes outside becomes 2, x to the power 4 when it's outside becomes x squared, and y to the power 6 when I take its root and remove it becomes y cubed, and everything that was left inside stays inside. That's the simplified version of that. That's simplifying radicals. Similarly, on your worksheet, you will be asked to group like terms, to add or subtract, and you can only group like terms if they have the same radical. These are like terms, and when you group them, you just add the coefficients. This is really the same as 1 root 7, so this becomes together 4 root 7. And something like this is not simplifiable, because root 5 and root 3 are not like terms. So that's it. You don't even have to write that equals to itself. In a slightly more complicated example, you might see something like this, where to see if things are combinable or simplifiable, you have to simplify each individual expression first. So 50 is 25 times 2, 27 is 9 times 3, 32 16 times 2, and 48 16 times 3. I picked these factors because each one has a perfect square factor. Those are the red ones, and when I remove them, I get this. Now I do have like terms. Now I have a root 2 and another root 2. Those are like terms. So 5 plus 28, it's 33 root 2. And these two terms are like terms because they both have a root 3. That's how that simplifies. Negative 12 root 3 plus 4 is negative 8 root 3. Last two things are multiplying and dividing. When multiplying radical expressions, it means that you multiply their corresponding coefficients, and you also multiply their corresponding radicals. So when I multiply these two, I'd multiply 2 times 5, and I multiply root 7 times root 3, and that stays inside the radical. It's not really like FOILing because there's no plus or minus between them, but it would be like multiplying 2x times 3x. The 2 and the 3 get multiplied, and the x's become x squared. Here, 2 times 5 is 10, and the two roots stay inside the root. If the value inside the radical is simplifiable, you should simplify it. In this case, it isn't. 21 does not have any perfect square factors. And something like this is something where you, now that you have a plus and a minus, you would have to double distribute that. So this would be something where I've got to multiply the two first terms, and then the two outside terms, and then the two inside terms, and then the two last terms. And again, if any one of these is simplifiable, you should simplify it. Here they are not. And finally, dividing radicals follows the same convention. I'll divide coefficients, and then I'll divide radicals. Now, 56 is simplifiable before I divide. It doesn't matter if you simplify first and then divide, or divide first and then simplify. Often what I'll do is divide first, because it makes the number inside the root smaller, and I might only have to simplify one instead of both, meaning the numerator and denominator. Here, 10 divided by 2 is 5, and then 56 divided by 7 is 8. That stays inside the radical, and then if this is simplifiable, I should simplify it, and here it actually is, because this is equal to 4 times 2. So the 4, which is a perfect square, comes out and becomes 2, multiplies the 5, and we're left with root 2 inside. The only new thing here is that when you are dividing, it allows for the possibility that you have a radical in the denominator, and if you do, you have to rationalize it, which is something that you will see in the next video lesson.